This is Dr.BDY Sunil, Associate Professor, Mechanical Engineering Department, Institute of Aeronautical Engineering, Hyderabad. In this session, we will be solving few problems on equilibrium conditions involving the moments and reactions. Let us solve a problem on moment principle. The problem given is, find the moment of 100 Newton force acting at B about point A as shown in figure. From the figure, the 100 Newton force can be resolved into its horizontal component as 100 cos 60 degrees and the vertical component as 100 sin 60 degrees. From Varignon theorem, the moment of 100 Newton force is equal to the sum of the moments caused by its component forces. Therefore, moment M is equal to 100 cos 60 degrees into 500 plus minus 100 sin 60 degrees into 400. Negative sign is used because for the vertical component force, the moment will be anti-clockwise direction with respect to the selected moment center, which gives the value of 25,000 minus 34641.0. That is equal to minus 9641.02 Newton millimeter or 9641.02 Newton millimeter anti-clockwise direction. So here, as per the direction of the force that is being applied with respect to the moment center, the clockwise and anti-clockwise directions will be selected likewise. This is how we will be identifying the moments along with the moment center with respect to the perpendicular distance of the force to the moment center. Let us now solve a problem on resultant and moment. The problem given is, four forces are acting at various places and in various directions on a bar as shown in figure. Find the magnitude, direction and position of the resultant force. In the given problem, only the force acting at P is vertical and all other forces are inclined. Hence, we have to resolve the remaining forces into their horizontal and vertical components. So the forces acting at Q, R and S will be resolved into the component forces as represented. We have to be careful in representing the direction of the component forces also. Let us assume that the resultant of these forces will act at a distance of x meters from P, acting at an angle of theta to the horizontal, as represented here. Now, the algebraic sum of the component forces is sigma fx is equal to rx, that is equal to minus 70 minus 707 minus 433, that is equal to minus 1890 Newton. Why we are taking negative sign here? Yes, as the forces are in negative direction. And the algebraic sum of vertical component forces is sigma fy is equal to ry, that is equal to minus 1000 minus 1299 minus 707 minus 250. That gives the value as minus 3256 newtons. So the magnitude of the resultant force is R is equal to under root minus 1890 square plus minus 3256 square, that is equal to 3764.79 Newton. This is the magnitude of the resultant. Also, theta is equal to tan inverse 3256 by 1890. That gives the value as 59.86 degrees. So this is the inclination of the resultant. Now for finding the position of the resultant, we will use the Varignon theorem. Taking moments about P implies Rx ry plus into x, ry into x, that is equal to 1299 into 4 plus 707 into 8 plus 250 into 12. Here we have taken positive sign because the moments are clockwise about point P. Therefore, x is equal to 13852 by 3256. That gives the value as 4.254 meters. Hence, the resultant of the force is 3764.979 newtons acting at an inclination of 59.86 degrees to the horizontal at 4.254 meters from the point P. Let us solve another problem on moment principle. The problem given is a roller of radius 0.3 meters and weight Q is equal to 2000 newtons is to be pulled over a curve of height h is equal to 0.15 meters by the horizontal force P applied to the end of the string wound round the circumference of the roller. Find the magnitude of P required to start the roller over the curve. In the figure, we can see the forces acting. One of the forces is the weight of the object and the other force is P, used to pull the roller over the curve. The roller is in contact with the curve at point A. Now, as the first step, we will draw the free body diagram of the given system. In the system, it is given that the force P is making the object to start the roller. Hence, when the sufficient amount of force P is applied, the roller starts to lose contact from the horizontal base support. So, there will not be any reaction from the base support. And at the point of contact of the roller to the curve, the roller tends to climb the curve by rolling. So, we can apply the moment condition of equilibrium at moment center A. That gives us the equation sigma m is equal to minus q into AB plus P into EB is equal to 0. Here negative moment is taken because the weight is causing anti-clockwise direction moment at the moment center A. For the required data of AB and EB, which are here, we can use simple triangle principles on triangle ABC. Solving the moment equation, we get P is equal to 1155.5 newtons. Hence, a force of 1155.5 newtons is to be applied so as to start the roller over the curve. Now let us solve another problem. The problem given is determine the resultant of the forces acting on the bell crank shown in figure. In this problem, there are 4 forces acting at various points and in various directions. The force representation is made as given in the figure. Now resolving the forces horizontally, sigma fx is equal to Rx, that is equal to minus 280 plus 200 cos 60 degrees, that is equal to minus 180 newtons. Resolving the forces vertically, sigma Fy is equal to Ry, that is equal to minus 400 plus 200 sin 60, that gives minus 973.2 newtons. Now the resultant R is equal to under root minus 180 square plus minus 973.2 square, that is equal to 989.7 newtons. The inclination theta is equal to tan inverse minus 973.2 by minus 180, that gives the value as 79.5 degrees. For identifying the position of the resultant, let us apply the Varignon's theorem. Taking moments about O implies Ry into x is equal to minus 200 sin 60 degrees into 300 plus minus 400 into 150 plus 400 into 150 cos 60 degrees plus minus 280 into 300 sin 60 degrees. Solving this equation, we get x is equal to 159 millimeters. Hence, the magnitude of the resultant is 989.7 newtons acting at an angle of 79.5 degrees and at a distance of 159 millimeters from the point O. Let us now solve a problem involving string tension and a hinged support reaction. The problem given is determine tension in the cable and horizontal and vertical components of reaction at pin A as shown in figure. The pulley P is frictionless. Here, the bar is supported by a string from the pulley at B and C and a hinged support using a pin at point A. Also, there is a force of 200 Newton at the end of the bar acting vertically downwards at point D. As the bar is held by the string, there will be tension acting in the string because of the forces in the system. the tension will always be acting away from the body, which is considered during the solvation of the problem. As the first step, we have to draw the free body diagram to the given system. In this free body diagram, the hinge support reactions are given as RAX as horizontal reaction component and RAY as vertical reaction component. Also, the tension in the string is considered as T, which is acting away from the body at points B and C. The inclination of the string is given as tan inverse 3 by 2, that is equal to 56.3 degrees at point C. Using this inclination angle, the components of tension at point C is deduced as 0.8319 T in vertical direction and as 0.5548 T in horizontal direction. The tension at point B is a vertical force. Now let us first apply the moment condition for the equilibrium of the system at moment center A, so that the tension T can be found. Hence, sigma m is equal to minus T into 2 plus minus T sine 56.3 degrees into 4 plus 200 into 5.5 is equal to 0. Solving this, we will get the value of T is equal to 206.47 Newton. Now applying the sigma fx is equal to 0 condition, we get Rax minus T cos 56.3 degrees is equal to 0, which implies Rax is equal to 114.55 Newton. And applying the sigma Fy is equal to 0 condition, we get Ray plus T sine 56.3 degrees plus minus 200 is equal to 0. Implies Ray is equal to minus 178.23 Newtons. Here, negative sign indicates that the vertical component of the reaction is acting downwards. Hence, reaction at A is given as R is equal to under root 114.55 square plus 178.23 square. That is equal to 211.86 Newton. And the inclination of the reaction is given as theta is equal to tan inverse 178.23 by 114.55, that is equal to 57.27 degrees. Thus, the reaction at hinge support is 211.86 Newtons acting at an inclination of 57.27 degrees. And the tension in the string is 206.47 Newton. Let us solve another problem. The problem given is determine the tension in the cable AB which holds a post BC from sliding as shown in figure. Weight of the post is 200 Newtons and assume all the surfaces as smooth. In the problem given, there are no extra forces acting in the system. The only forces that we are able to see here are the weight of the post, which is 200 Newton, and as this is the weight of the body, it will act vertically downwards. Then there will be reaction forces at the contact points of the surfaces and the upper portion where the post is resting on the sharp edge, and tension at the bottom of the post where it is tied using a cable. These things will be shown using the free body diagram of the system. As shown here, let the post is resting on the sharp edge at point D. Hence, at point D, there will be a reaction force Rd acting normal to the surface and towards the body. By simplification, we understand that the inclination of the reaction will be 30 degrees from the horizontal. Also, for obtaining the BD length, we can use simple triangle laws and deduce the length from triangle ABD as sin 60 degrees in triangle ABD is equal to AD by BD, that is equal to 4 by BD. Therefore, simplifying this, we get BD is equal to 4.619 meters. Also, the weight 200 Newton acting vertically downwards will be at a distance of 2.5 cos 60 degrees horizontally from the point B. This is useful while we evaluate the moments. The tension in the cable AB is given as T, which is acting away from the body, that is post. All these data can be deduced by the help of free body diagram of the system. Now, let us apply the equilibrium condition to the system for finding the unknown forces acting in the system. First, let us apply sigma fx is equal to 0. This implies T plus minus Rd cos 30 degrees as the horizontal component of the reaction force is in negative x-axis direction is equal to 0. Simplifying this, we get T is equal to 0.866 Rd. Now let us take the moments above P. This gives 200 into 2.5 cos 60 degrees plus minus Rd into 4.619. As the perpendicular distance of this Rd reaction is directly known, there is no need to apply for individual component forces of Rd, that is equal to 0. Simplifying this, we get the value of Rd as 54.124 Newton. Now, substituting this value, Rd value in tension equation, we get T is equal to 46.87 Newtons. Thus, the tension in the cable is 46.87 Newtons. By this time, you may have understood that there is no need for applying all the three equilibrium conditions in all the problems. We may use the equilibrium conditions according to the requirement of the problem for obtaining the unknown forces. So this concludes the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.